Hello and welcome to today's demonstration and discussion of the current understanding of gravity. While this is a subject that is still under a lot of study and a lot of the theories that we have are simply that, they're theoretical, and being able to produce the truth is usually in our modern setting done through scientific investigation. So today I wanted to demonstrate with our universe and my handy dandy fabric of time and space, which is actually one, but we'll get into that later maybe, how exactly gravity affects space-time. So if we see this as a perfectly flat space-time, and this is of course a two-dimensional plane, but we have to think of it as a three-dimensional plane, which means that it has both depth, width, and height. I can only figure out how to demonstrate this on a 2D plane, so just use your imagination and think of how this would be on a three-dimensional field. And this is essentially our current concept and grasp and understanding of the way gravity works. So if you take your perfectly flat space-time and you drop Mercury into it, let's see what happens. Making my space-time flat. You can see that it's caused, or maybe you can't really see, my video is not very perfect, but there is a slight ripple in it. There's a dent where the mass is. Now, let's take a larger object. In this case, I'm going to use my representation of Jupiter, and let's see what happens whenever we drop it. So there you can see there's a much bigger divot and dent, and this is basically the way that we understand gravity. It's always going to be according to the mass of an object. So something as big as Jupiter has a much bigger gravitational effect on space-time than something like Mercury. So let's go ahead and we'll put Jupiter down, and then let's see what happens to Mercury whenever we put it near the orbit or near the gravitational pull of Jupiter. So you can see it spun around a little bit first, and then it reaches and it collides actually with Jupiter. So the idea behind relativity, is what Einstein has called it, is the dependence of the gravity is relative to the mass. So a larger mass is going to have a larger gravitational field and a gravitational pull. Just like the indent is much bigger whenever you have Jupiter versus Mercury, also Mercury is going to collide eventually with Jupiter because of the much larger gravitational pull. This hasn't happened yet because the sun is actually pulling and creating a much larger gravitational pull, and basically all the planets are spiraling around the sun, and the sun is spiraling around something even greater, something called a black hole, but that mass is so great that it's pulling even our sun along with it. That's a very deep subject that we can get into at a later time, but for now I wanted to conclude just with this brief explanation of relativity. Thank you.